Hello, this is Peter Newman from the ANSYS student community, making a video for a user who's kindly updated their username to Han Yu. Hello Han Yu, and I'm going to look at the model Han Yu sent, and there's a issue with it solving. So this is the model, and what we see is that it's a contact model, and if we look at solution information and set the output to force convergence, you can see that it did some steps and then it needed to cut back. It did another successful step and then failed to converge, and what we can do is see the last time step before it failed. So this is the last successful time step, and what that is the initial contact. So that's the point at which it failed. The point at which it started is back here, and so all the successful time steps were just advancing this forward, waiting for contact. So, and then one improvement to the model is to go into the design modeler and translate these until they're just touching. Then you won't waste any time in static structural computing, moving the parts together. You'll just move them in the CAD, and it can start with initial contact. So the other observation is when we go look at the frictional contact, which is the key to this problem, we see that there's contact face that does not include the blend around the corner, and so that means this sharp edge at the edge of the blue is going to hit the red, and so that'll be edge to face. If this face is added to the blue, then it will be face to face and more likely to succeed. So we'll look at that and see if that can let it continue. The other observation is there's a lot of contact to glue parts together with bonded contact. So one way to eliminate all that overhead of additional elements to bond things together is to go into Design Modeler and create multi-body parts. So we've got 6 parts here, and bonded contact to glue those together. We can instead pick the bodies like this one and control key this one and this one, and then with those selected in let's hide them so we can find the other 3. So now we know that these 3 parts all move as a rigid body, and they're all intimately bonded together. So we right click and say form new part, and then we do the same with these 3 parts, form new part. Now we've got what we can call the spring, and maybe what we can call the plug. Now we back in this module, we don't need any of these contacts, so we can delete them all. Delete all the contacts because we've created a multi-body part. And what we also want to do is edit the faces to add that little blend in. That's as simple as, on the blue side, control click to add that face, and go to the other side and pick this, hold the control key down, and add that face in, apply. So that is one thing to do. Another thing is it may at some point fail to converge because the elements are too large. So you want to know where the elements are having trouble, and you can find that out by clicking on solution information and telling that you want the Newton-Raphson residuals to be say 3. So for 3 of these dots you can find out which, or the last 3 dots, you can find out which element was struggling to converge, and you can use smaller elements in that area, and then on the next solve it will improve the chances of converging. So going back to static structural, and we're going to show all parts, and we're going to move one of these up a little bit. So we need to create, I think it's transformations, translate. So we're going to translate say this plug, and we're going to translate it in direction definition, probably the XZ plane, and we can translate that minus, that's too much, minus 10, -12, so we want it just touching, so maybe we could have gone just a little further. Generate, too much, so 12 is probably a good number, 12.2, there we go, and that will let the, let's go one more, 12.3. If it is touching at the beginning of the simulation, then it doesn't have to search for the first contact, and there's an adjustment called adjust to touch, which will offset these by some small amount and let them touch. And that's getting pretty good. So make sure it's symmetric. Yep. So that is my recommendation for changes to this model, and I'll pause the video now, and we'll go back. You need to refresh the project to have those changes flow into mechanical from Design Modeler, and now in mechanical it automatically made contact region, which we don't want. So we just delete that, or suppress, because it'll create that each time we make changes. And the other thing is to insert a contact tool. Oh yeah, we already had one. I'll just delete the first one, and in this contact tool we want to generate initial contacts, and it'll find that it's still working on that. It'll find that it's not yet closed, it's got a tiny gap. We want it to be closed, and we will accept a tiny offset of the surfaces. So we will edit that surface and tell it to geometric modification is to adjust to touch. So now those two surfaces have been tweaked so they are closed, and if we were to recompute the initial information, it will be closed, and that will help the solver start opening that clip instead of just being moving through space up to that. So let me just start the solver. We've turned on our residuals, so if we say solve and it fails to converge, we can look at the plots underneath solution information to determine where the mesh needs to improve. And improving the mesh is always part of any computation. So we're begun the solution process, and let's also check, this was in the last video, the analysis settings was large deformation turned on, and it is large deflection, I should say, so that's also required for any contact model. So I think we have liftoff here, and we're looking to see these, yep, so we have our first converged iteration that includes contact, and from this point on it's going to advance that clip forward, and the contact will be working for you. And there's another converged substep, so I think we're going well, and I will pause the video now.